Alright, let's go ahead and get started today. Oh, I remember I shrank myself down in this last one. Let's go ahead and shrink and make myself a bit bigger. Whoop! Let's see where I am here in the recording. Oh, that's nice and fractally. Okay, there's fine, I think. And then let's go ahead, we move that there. And now we need to go to, we'll go and check out Canvas. Right? So today we're going to be working on from the textbook again, which is fun to call it that because of course it's not actually a book, you know. It's well, not physically. All right. So go into here. So I've started running the grader for, I think I've ran it for chapters 1 and chapters 2 last night, so you should be able to start seeing grades there. I'll try to run the rest of the grader, the things for the grader tonight. Even though the grade me, but first off, the grade me button will disappear after I run the grader. Don't worry about it if you need to make adjustments. If you make any adjustments and save your changes, right, or select different responses, and then I run the grader again, it will take that into consideration, so don't worry about it. Okay. Second thing, I've been asked about questions about the exam. I got to think about that because there's basically two possibilities for the first exam. Okay, so let me pull up this. Let me pull up the. Let's see. Let's see. Let me go ahead and mute my. Nope, not that. Video capture device. There. So I'm muting the camera there for a second so I can pull this up, right? We have, so next week is, so this is week 4. Week 5 would be the 24th. So now I could give them, now what I'm debating is giving the exams in lab versus giving them in person. If I give them in lab, that means that your exam date depends on when your lab is, which would be either the 1st or the 2nd or the 4th or the 7th, which gives a lot of spread out time, but it means also I might have to create multiple exams to accommodate for that. So that's one possibility. The other possibility is that I do it in here, in which case it would be the exam date would be the 3rd, right? Both of these have reasons to do it. Logistically, doing it in lab is easier and it gives you more time, but then the exam, passing answers from one student to the other can happen, which is kind of, so I've got to think about that. On the other hand, it's hard. On the other hand, I don't know. So I'm still thinking about it. What I can tell you is that next week you will get your practice exam. I do a practice exam, and the way this works is I've made twice as many questions as I've needed to in the past. When I first started writing these exams, I made twice as many questions as I needed to, and I just simply took half of them and handed them to the students, right, and then put the other half in the actual exam. So these are questions I would have put in the exam in an alternative universe, essentially. So So they're very good and accurate representations of the exam. It's a good way to test yourself to make sure that you understand the material, okay? And it's going to basically, the big things it covers are for loops and turtles. Specifically, what does it mean? Specifically, I'm testing you on for loops using turtles. You will get things like, questions like, please draw the output of this code, right? Where I'll ask you to draw something. And now, in case you're worried about having to bring a protractor, I try to make it so that the turns are basically either a third, either they're a 90-degree turn, a 45-degree turn, or a 30-degree turn, right? Something that you would be, basically, are you doing a triangle, a square, or an equilateral triangle, So very easy turns here is the kind of point that I try to make. Okay, nothing that you should necessarily have trouble with, and besides, if your angles aren't exact, I don't care, right? It's not, if your thing ends up looking lopsided because, like me, you're terrible at drawing, whatever. I'll be able to tell whether or not it's right or not, okay? Another thing that we'll be using the turtles for is the stamp function, which draws dots, which is sometimes easier than drawing lines. But that's primarily the thing where there'll also be things where I give you a picture, right? I say, here's the turtle output, right? And I want you to fill in the blanks on the page to make sure that it draws this output, right? And a lot of times this is just simply giving you a for loop. They're not really trick questions. It's just to draw like a nifty figure or something like that, okay? I think last year the only angles I had were 45-degree turns and 90-degree turns, right? I kept it simple last year because that makes the drawing very easy. Okay. There's also some basic stuff about mathematics there and some stuff from the very, very first lecture. So by mathematics, I mean like, evaluate these expressions, like making sure you remember order of operations, and making sure that you understand the difference between divide, and modulo, right? Just making sure you understand those and understand those in very kind of basic ways, right? If you see big numbers, know that if you see big numbers on a question, you know that means that question's actually probably easy, right? So that the math is actually very easy, and it's just meant for you to kind of look past the numbers at what I'm actually asking there. So as far as the final exam, because I've had a few students ask me about the final exam and when that is, the answer is yes, I actually am breaking campus rules by not putting that date in my syllabus. Because I don't want to accidentally accidentally put in the wrong date. The way I know what the final exam is the way you all should know what the final exam is. So we're going to figure that out right now. Okay? So, a couple things over here, because it's good to go over this now rather than later in the semester. If we go to look for Temple Academic Calendar 2024, right? This comes up over here. Okay, so that's what I just do. You go to the registrar's page or to the bursar's page, assuming it will load. Sorry, it's just like not really doing something today. Come on. There we go. Where is academic calendar previous? So if we go over here to previous, other important dates. So yeah, there we go. I went back on that page, and I go over here. Other important dates. Final exam schedule. This is how we know this is how everybody knows when their final exam is. Doesn't matter what the class is. So I find it very silly to have to put them in our syllabus, because I could accidentally copy the wrong date in, and I have accidentally copied the wrong date in. And let me tell you, that makes it a real headache. So none of that. No introducing a second point of failure when I can just simply tell you to go here. So here you go, fall 2024, from December 11th to December 17th. A day class, either it's a day class meeting, and then evening classes are over here. Now, while this is a 4-credit course, we look under the 3-credit course credit because that's when we're meeting. You have 3 lecture hours and 1 lab hour, right? So we look over here, and Tuesday, so it's on. So we go from 2 to 3:20 Tuesday, Thursday. So that's us. So it's going to be Tuesday at 12:17 from 1 to 3, which is one of the either best or worst slots, depending on it, because that's like the last day of finals. So that's what it is almost always for this course. For data structures, the other class I teach, the final exam is typically a very tough for the students, not because it's a tough exam, but because they're just exhausted by that point. So, be sure to pace yourselves there. Okay? 12:17, 1 to 3. Okay? Also, there's some classes have a, common section where basically all the sections get together at the same time and place. Okay. There is one reason I brought this up, though, because there's a bunch of verbiage that I skipped past. You should not skip past this. You should read this. For instance, final examinations may not be scheduled on study days or in the last week of classes. In other words, the professor can't just simply schedule their exams on the last week of classes, before 12/10. They can't schedule it the first week of December so they can just skedaddle for a long winter break. Okay, that's not allowed. Same thing. Study days. those study days for, there is one study day this semester before a final exam starts. So you've got that hanging Monday, and then you've got 12/10, which is a study day where there's no exams. Your professor can't go, well, that's a juicy spot where there's nothing going on. My students are free that day. They can't do that, okay? If your professor does do that, email the dean. Like, that's not cool, okay? Unless they have it might be that they have a special circumstance worked out with the dean, in which case they'll let you know about that, the dean would, but otherwise, you know. The other thing to note is that you're only allowed 2 final exams per day. If you're scheduled for 3, as sometimes happens, it's weird, it shouldn't happen, but sometimes it's happened, the student is scheduled to take 3 final exams in one day. At no university is that considered cool. I don't know why, it's just kind of one of those unofficial rules that doesn't vary from university to university. You're allowed to be stressed out twice a day, but apparently 3 times is one too many. So in that case, you are allowed to ask one of those 3 professors, please move. And it may be trouble finding a professor to accommodate you. I'll always accommodate that if that's the case for you. But like, just know that you should, let that, you can figure that out. So again, any of your courses you can find here on that matrix over here. So, but that is how I find it out. I will email these all out much later in the semester. But because I had gotten so many, very proactive students who are trying to get their schedules down, and I understand that. But there's just being proactive and just wanting to know where everything is on the calendar. For a lot of international students, that's trying to figure out flight plans so you can maybe go home and visit, because a couple days can mean thousands of dollars, right? So, that nothing's wrong. I wanted to make sure that you all knew where that was and where that information was. Part of teaching this in the fall to a bunch of freshmen is just making sure I can give you all knowledge like that. Okay, so today we scroll down into modules and we're going to go to module 4. So, I need to be very clear, and if you hear nothing else today, hear this. If you are having trouble in the class, this is the week to let me know. If you start having trouble in the class, this is the week to let me know. If class is going too fast, this is the week to let me know. Okay? Because this is the time where A, trouble begins, and B, I have the capacity and the willingness to adjust things so that things can occur at whatever pace they need to be. Because if the students are not understanding the material and I just toss you into the exam, well, it's going to be a very accurate assessment that you didn't learn anything, but I want to make sure that you get the chance to learn things. You see, there's no reason to punish you for not learning things if you haven't had the chance and we're moving too fast. Okay? Now, generally, we don't have to slow things down. Sometimes it's just a matter of meeting with me for an hour over Zoom to make sure that things get hammered out. But if you're having trouble, let me know, please. It's literally my job to help you. Okay? Literally, the university gives me money. They pay me to help you. That's my job. It's what I get paid to do. So don't feel like you're imposing. Okay? Especially you'll be like, oh, I'm meeting you over Zoom, Zoom while you're at your home. Yes, that's kind of deliberate. That's kind of the point. It's one of the perks of being able to have a job like this one, that I can be flexible and meet with students on whatever time they need to be. And I can then also be there at home for my kid if I need to be. So it's a very flexible kind of thing. So don't feel bad okay, but I'm emailing him after hours, or it's that. The only time where I'm not available is going to be sundown to sundown from Friday to Saturday, okay, for religious reasons. That's the only time where I'm not available. And even then, if it's a big emergency, I'll still respond, okay? But other than that, after sundown, sure. Before sundown on Friday, sure. Okay? Don't feel bad about reaching out to me. Okay? So, we're going to be going over turtles, sequences, and for loops. Sequences are going to be more of a post this exam thing, but they're very good for showing how we can mess around with the for loops. Because for loops iterate over things. For loops go over things. They go through it. You go through every individual item in a collection in a for loop. That's how it works. Okay, so chapter 5 in your textbook goes over through turtles. Chapter 6 goes over through working through all of these things. Hopefully you have the chance to look at this, to watch these by Tuesday, but if you haven't, well, again, that's why we're here. Also, for this next lab is lab 4 and 5. It's a larger lab. It's worth 180 points as opposed to so it's worth around 2 assignments worth. There's also 15 points of extra credit you can earn on it. This lab is the focus of 2 weeks, hence the longer due date, right? Some students, they find it fine to do. They find it's like a week's worth of work. Some students, it takes them the full 2 weeks. It's fine. It's meant to be a longer lab because we're doing these things. It's broadly speaking split up into 2 parts, which your TAs will go over. And it does teach us how to do functions. The first part can all be in the same file, okay, which is 3 kind of text-based for loop problems. The second part deals with turtles, and we move from drawing a square to drawing a row of squares to drawing a grid to drawing a staircase, okay? The entire point of this is that all 4 of these functions should be in the same file because, well, what you're going to do is you're going to write a function, which is a mini program, to draw a single square. Well, drawing a row of squares is just doing that function, that single command that you just wrote a whole bunch of times. Okay? And then drawing a grid, well, that's just a pile of rows, ain't it? Right? And then a stairs, that's just a pile of rows of different length. Right? Where each row is a different length. That's all that is to it. So but what we're trying to teach you here is how to build up from one basic command and kind of build up, use those as building blocks to make more complex commands. And then there's this other spiral one, which is going to be very similar to one you've already done. And then just a fun art thing. These are the kinds of fun things you get to do with turtles, which these look, this looks really complicated to draw, but all this is I think a bunch of, it's all it is a bunch of hexagons layered on top of each other that share a corner. That's it. That's all this is. That's all that is. And then there's, again, 3 5-point extra credit problems, okay? So plenty of opportunity for those. All right. So going back to here, let's go ahead and click on the Tuesday link for the textbook, which is creating random passwords. Okay. And I'm not logged in, but that's okay, because at the beginning of the last lecture, I had to log myself out of everything so I could get my grade book. Okay. So again, you can either click on the link if you're logged in, and it'll bring you straight there, or if you just have to log in, you click on the textbook, Foundations of Python Programming. You scroll all the way down. I'm not even looking at the screen anymore. There we go. Okay. And then you select Project 5, Generating a Password XKCD Style. Now, XKCD is a web comic, right? Hopefully, hopefully you've found something that you like. Some of them are great. I like Saturday Morning Breakfast Cereal. That's an awesome web comic, SMBC. I'm also a big fan of XKCD, which is, I don't think that stands for anything. And it has a lot of math and computer science jokes, and it's pretty good. This one is a comic about passwords and password policies. Temple actually has an amazingly good password policy. I think somebody must have actually read this comic. So here's a comment. So this first panel, it's a common password, right? You have somebody here used Troubadour as their password, but then they did a bunch of things that passwords ask them to add, which are random numbers, right? Then capitalize some of those letters, then and also do some. You need a random symbol, although sometimes that's limiting you to a subset of symbols, which is very annoying. But the point being is that it's a fairly short thing. Okay? Now, you can measure this kind of in the complexity in entropy, which is trying to just simply nail down, how complicated it is to figure it out from nothing. But the point being is that he estimates that this is about 28 bits of entropy, which means that it's about 2 to the 28 possibilities. Okay? Which is a big number, but not that big which takes about 3 days to crack that password at 1,000 guesses a second, right? Not that long. This is an easy thing for a computer to crack, in other words. Whereas assuming there's no other password protection considerations, which there usually are. But for you, right, was it trombone or troubadour? And which one of the zeros was an O, right? Okay. But also there was a symbol, so it's hard for you to remember necessarily what it is, right? Troubadour. If I asked you if I muted this, right? If I muted the screen and told you, okay, what was the password? A lot of you wouldn't be able to write it down because you weren't trying to memorize that. Whereas this one, correct horse battery staple, which is just simply 4 random words, has a lot more complexity because it's a lot longer in terms of character length. But for a human, well, you've already memorized correct horse battery staple. There you go. You've already memorized it. It's an easy to remember password. Temple's actually great. When you were creating your password, you may have noticed that as the longer your password is for Temple, the less requirements there are. If you go up to like 16 characters, by the way, for Temple, they'll just let you use all lowercase letters. It's fantastic. And this makes it a lot harder for you to get, for a computer to guess, a lot easier for the human to remember, so long as you don't write it down. Now, if we're going to be honest, most security kind of things happen because of a human error, be it writing your password on a sticky note and sticking that somewhere that's easily accessible, somebody's keys getting pickpocketed, their badge being pickpocketed, or my personal favorite, hello, I'm from the password department, from the local county password department. I'm doing a password check. What's your password? People are not very smart when it comes to computers all the time. It's just the way people are. It's a tool, and we don't necessarily think that giving access is really good. Yes?
Isn't that more an example of social engineering?
Social engineering is almost always a superior method of getting into places for most cases. It is the easiest way to get in. It works, and it's effective. Convincing somebody else one of my favorite videos from DEF CON, from one of the DEF CONs, is a reporter basically saying, okay, how easy is it for you to get onto to get access to my cell phone plan and get me off of it, and instead get you on it, but I'm still paying for it. And she goes like, well, it takes her about a half an hour. What she does is she just plays a YouTube video of a baby crying in the background and then proceeds to just play the role of a completely overwhelmed new mother. And of course, because it's an overwhelmed new mother who just changed her name and other stuff has happened, that, the agent on the other end of it is all the more willing to help. It's very effective to attack people and attack people's brains rather than to attack the devices themselves. Although attacking the device itself and just simply stealing it is also a viable solution. Like, we can think about all this cryptographic engineering instead, but it doesn't really, but there's a lot of different avenues for attacks. So anyway, that's a mini spiel of mine. I'm very passionate about the social engineering aspects of these kind of things. So anyway, the punchline for this one is that through 20 years of efforts, we have successfully trained everybody to use passwords that are hard for humans to remember, but for computers, easy to guess. Now, of course, there's other kind of things that are built in to prevent these kind of things, such as how many attempts somebody might get on a password, right? And very rarely are passwords stored in plain text. Typically, what you have is what's called a hash. You'll learn more about that in 2168 if you take it. But regardless, let's go ahead and make something that a lot of us do use these days, which is a password generator. Okay? You probably, if you use one on, you probably have one on, if you're using Firefox or Chrome, right, where you sign up for a website and it will offer to make you a securely generated password and store it in the web browser for you, right? So the idea here is, how do we make passwords? Okay? So we're going to use two tools here. First, we're going to use the we're going to use a for loop to do repetition. And the second thing we're going to use is a module called random. Okay? Import random. Now random generates statistically random numbers. They are pseudo-random. They are generated deterministically. Okay? This gets into there's this whole kind of philosophical discussion we can have about whether is anything in the universe truly random or not, right? If I could recreate it from the Big Bang and I knew the starting principles, could I predict all this stuff happening if I had enough information, right? No, that's a discussion for philosophy class. Here in mathematics, we care about, is it statistically random? And that's what we mean. That means that if I ask random to randomly choose letters from this variable, it would choose things equally at random if we tested it at enough time, right? Approximately equal, because randomness does mean that it could go biased towards A's if you run it for a short enough time or a long enough time. All right, so random is useful for choosing things. Now, in other programming languages, what we'd have to do is we'd have to actually add in a few steps. Like, okay, I need to get the index of an item. An index being where in this position is this? Like, where in this variable is this? But here, Python's going to allow us to do that with something I believe called random.choice. Okay? So we have three variables here. We have letters, which is undercase letters, and it's less of a message, right? It's just simply A, B, C, D. It's just all the letters glommed together in a string, which means it's easy for us to go through. Capitals, likewise. And numbers, also likewise, right? It's very self-descriptive as those are. But why do we have them like this? Because we can use the random module to do this. And what do I mean by that? I'm going to go ahead and print random dot choice. And then I can say something like letters. Okay? Random.choice, what that does, all right, let's just go ahead and select that out and put it in a comment by itself so you can easily reference that. What does that do? All that does is it does what it says on the, it says, let's go in let's look at the random module that I imported. The dot says, let's look inside of it. And the choice says, okay, this is the function inside of it. A function basically being a verb in the programming language. We learn how to write our own functions, but this is one that was written by other developers for us. Let's look at the choice function. And what choice says is, given a collection of things, a sequence of things that they're called in Python, given some sequence of things, I want one thing from them at random. And it's uniformly at random, meaning any option, and you can see it on the bottom left of the screen, any option is equally likely. Right? S is likely. I just ran it and hit run again, and it came up with S again. That wasn't unlikely. Two sequential S's, that has a 26 by 26, that's a 1 in 26 by 1 in 26 chance of happening, which is bound to happen one semester or another, especially if I'm just keep clicking it like this. Okay? Okay, and there's all this fun algorithm that you don't need to understand. I think it's called the Mersenne prime twister or something like that helps generate random numbers based off of the seed. You don't need to know any of that. All you just got to know is that, okay, it's just giving me a random number every time I hit run, or a random letter. It's giving me only one of the lowercase ones because that's what I'm asking for, right? If I did caps instead, it would give me the capital letters, and if I did numbers instead, that would give me the numbers, okay? And of course, the goal here says, let's make a traditional random number, it says 8-letter password, by combining letters from these 3 strings, right? So what does that mean? Well, let's go ahead and take a minute, and rather than making one thing, let's just focus on writing a for loop to print out 8 random letters, okay? So just take a minute and write yourself a for loop to print out 8 random letters. Then we'll move on to making an accumulator, okay, with strings. So just review, how do I write a for loop? It's for blank in thing. What is the thing in this case? Well, the thing here is the number of times I want to run it. So I need to use the range. So just take a minute to do that, literally just a minute, then I'll throw it up on the screen. The next step is going to be making it across. Let's go ahead and get everybody kind of caught up. Okay. Looks like a lot of you got it. And if not there, just, devote some time to practicing if you weren't able to get it. You want to make sure that you can practice on this. That's the only way you're going to be able to make sure you're ready for the exam. Okay? So random out choice. So to print out 8 letters, what we're going to do is we are going to just simply do a for loop. For I, doesn't matter what it is, in range. And we want 8 letters. We want to print out 8 letters. So we do for I in range 8 to print out 8 things. And then we're going to print out a random letter. Oops. What did I forget? Yep, all the time. That was an unforced error on my part, by the way. I didn't do that deliberately. It just happens sometimes. It's okay. Okay? So here we got 8 random letters. And if I run it again, we get 8 more random letters. Now, of course, these are going horizontally, and that makes it a bit hard to store for us. So what we're going to do is we're going to do an accumulator. Now, we've done the accumulator pattern with addition before when we were doing pi. Simply put, that basically meant like we were doing something like this. X is equal to 0. This is where we've seen it previously. We were doing it with numbers, and now we're going to do it with letters. We did it like something like this. For I in range 5. Right, I'm going to delete this part in a bit, but it's fine. X is equal to x plus 1, print x, so print x, right? And then that would just simply add 1 5 times to the answer. Or I could do something like x is equal to x plus I, so add 0, then add 1, then add 2, then add 3, then add 4, right? Which would give us 10. We've seen this basically here. Take what was in the variable, add to it, and store it in another variable. It just happens to be the same variable. Okay? Here, though, the key is that when we are doing addition like this, okay, when we're doing an accumulator using addition, we're always adding from a starting point, which is 0, almost all the time, right? Because we're trying to see what the sum is. Here, when we're adding together letters and we're gluing them together, we're effectively going to do the same thing. The only difference is that what is our 0? It's not 0, right? Because password isn't a number, it's got to be a string. So we use what's called the empty string, which is just literally a string with nothing in it. Not even a space. That's not an empty string, it's got a space in it, right? Kind of tricky because of white space. No, this is a empty string. So, what we do here is that now, as we choose a letter, rather than printing it out, we are going to add it to the password. We're going to say password is equal to password, right? Well, so if we password plus random, well, let's go ahead and make this actually a bit shorter. Let's call it maybe car over here for the single character. Car is equal to random dot choice, just to make it easier to read. That's why we're doing this. Letters. And then that keeps this keeps this next line nice and short. Select so 8 times. What we're going to do is we're going to select the letter at random, okay? And then we're going to add it, right, to password, to the end of password. And then I run it, it does nothing. Why does it do nothing? Yes?
You did not print something out.
I did not print something out. This will happen all the time. I do it all the time. That one was a forced error. Okay, that one I did do on purpose. Now, the point being here, though, is this is a common thing, right, where you do all the work and then you forget to print it out. The first couple of times it happens, it's going to bug you for a few minutes and not be able to find out why. But once you spend enough time on that error, it becomes kind of part of your mental checklist of things you accidentally do as a human being. Okay? Just to be clear, okay, just so you understand what I mean about errors being common, there's been exactly twice during my entire undergraduate curriculum where I went into the lab or, either to work on something, and I spent basically the entire time, just beginning to end, just running the code perfectly, where basically there were no errors whatsoever the entire time that I was programming. Just twice in my entire time of doing assignments as an undergrad. Okay? Making errors is a common mistake. Those times stood out because they went effortlessly. And the only reason they went effortlessly is I put a lot of thought into them beforehand. Okay? Okay, so making errors and coming across stumbling blocks is really common. Okay? So there you go. So, Jim Drut. So, very interesting password. But now we need to actually make this a bit more effective. Okay? So it says we want to combine characters from the 3 strings. So we don't want it to just be letters. We want it to be randomly composed of letters, numbers, and characters. Letters, capitals, and numbers. All right. So how do we solve that? How do we choose from 3 things instead of 1 thing? Anyone? Yes. Yes. But the answer is it's kind of a trick question. How do we choose from 3 things rather than 1 thing? Make those 3 things 1 thing. That's what we do. So instead what we're going to do is we're going to do letter. We'll say maybe we could call it password characters, or we could just throw them into here. Okay? We'll just throw them into here. No. We'll call them, I already used car. Sorry, I try to keep my variables meaningful here. Options, that's a good one. Options is equal to letters plus caps plus numbers. And just to kind of see what that is, we'll also print out options right here. Right? So here, letters. So now we have all these. Now, rather than selecting from just letters, we'll select a random character from this ginormous string right over here. Make sense so far? From a ginormous string. Options. So this is IZIDIDoc. We didn't get any numbers, but that doesn't mean that it isn't working. It means that random is random, right? Here we got K9 Yanind. I don't know. But it's a nice random password, right? It's gibberish, which makes it great randomness and horrible for you to remember. But hey, we did that. So now all I'm going to do is this should work this time now that I'm logged in. I'm going to hit share code. Woohoo! Shared code with 245 students. So I know there's not 245 of us in this room. Some people do take advantage of the fact that I do record these. So if you were watching this because you just stayed home to catch up on this and weren't sick, please come to the class. It is a lot easier when you're in class. Trust me on this one. So now if we go to and run, so now if you refresh the page by either hitting this button or hitting F5 or function F5, right, you should see my answer that I shared with you in your timeline as the most recent thing. Or if you ran it after I shared it, then the second most recent thing. So it's now, but in effect, it's now stored in your textbook, so you can go back to it. So it makes it so if you had trouble furiously coding everything down while I was typing and erasing and stuff, there you go. It's right there for you. The refresh button. So either here or the key command on most computers is F5. Although some computers these days have it so like the F5 command, like the function keys are tied to things like increase volume, increase brightness, decrease volume. If that is the default action, then what you have to do is hit the function key on your keyboard and the F5 to get the actual F5 effect. F5 is almost always refresh. F1 is almost completely always, without a doubt, it is always help. F1 is almost always like, give me help. Although, it doesn't really do too much these days. So the other one in web browsers, besides F5 being to refresh it, is F11, which does full screen. Which can be useful sometimes, especially if you get distracted by being able to see your tabs. Although, with Firefox, and most browsers, if you go up to the tabs, they'll just appear again. But it's nice to be able to get, fully see that. Okay, anyway. So now, the next step. What the world is this nonsense? Now is equal to open bracket, tissue, comma, processor, comma, headquarters. These things with brackets are the other kind of sequence. So all you have to know, for practical purposes, while I'm going through this, is that you're going to use these the exact same way you did strings. These are also sequences, so the for loop works the same exact way. The accumulator will work the exact same way, okay? And more specifically, random.choice will work the exact same way, okay? But what is this? When you see, so let's go ahead and actually break this up a bit. Let's see. So what's at the end of it? So it's got a close bracket. Of course it does, because that's not surprising. Open bracket, and then you know it's done by there being a close bracket. Right? So what does that mean? Well, this is what we call a list. It's what we use when we need a variable to hold a lot of variables instead. Rather than a variable holding one thing, we need to hold it to hold a lot of things. Right? I keep talking about for thing in a collection. Well, you don't necessarily want to put that entire collection in that for loop. That would make the for loop ginormous. Here we have these things already written out for us. So nouns is equal to tissue, processor, headquarters, favorite, cure, ideology, funeral. These are all nouns, right? It's a list of nouns. That's all this is. It's a list of strings. How do you know when one begins and one ends? The commas, right? That separates the things in the list. Just like how you would do so in grammar, right? And when you're writing a list, maybe you'll do it as bullet points, but that's fine. For the computer, they use the commas as the bullet points. And then to know whether you're done with the list or not, or you're beginning a list or not, use the brackets, right? The brackets on an English keyboard being right to the right of the O and P keys, right? Right above the Enter key. On a non-US keyboard, UK keyboard, that's actually going to be in a different location, believe it or not. When I was teaching in Japan and was trying to get myself an external keyboard, but let me tell you, it was a bit of a trick to find one that was set up like the US, because those have different, you know how like when you do shift 4, that gives you the $, or shift 7, that gives you the ampersand, or here's the big one. Shift 9 gives you open parentheses, shift 0 gives you the close parentheses. Well, in the Japanese keyboard, that's not the same. I think it's like shift 8 is the open parentheses and shift 9 is the closed parentheses. So it takes some adjustment sometimes. You get used to it though. And don't get me started on those weirdos who use Dvorak. So take that, the one person in class who probably uses Dvorak, probably only one. Nah, it's fine. I just tease. All right, so nouns, verbs, adjectives. 3 separate lists. Okay, so now make a 4-word password by combining the list from the list of nouns, verbs, and adjectives. Okay, so here we did this. We started out with a blank password. You're going to do the same exact thing. Start out with a blank password. Okay. Here, the options for combining letters, for combining strings, adding together strings, glue them together. So let's just open up idle for a second to just confirm some fun facts, okay? When I said these things work exactly like strings, and you should treat them exactly like the strings we did, I meant it, okay? So let's try that. So L for list is equal to, let's do 1, 2, 3. Okay, no problem. And then S is, let's see, LM, right? 4, 5, 6, okay? L plus M, right? It's not going to add 1 plus, now you would expect, if this was math, you know, if these were arrays, you'd expect them to add, but they're not arrays, right? Because they could be strings. In fact, let me be clear as to what the answer will. Oops. Let me actually make this a bit more clear. Instead of the M being 4, 5, 6, we're just going to make them. Whoops. Instead of that, we're going to make it A, B, C. So now that we're adding together L and M, that should be a lot more intuitive of what that is. You're gluing them together, just like you glued together a string, right? Make sense? Right? You concatenate with the plus sign. These are lists. They're not arrays. They're not vectors. They're not matrices. They're lists. They just happen to use the same kind of key. So they just happen to use the same kind of brackets. That's fine. And also, one of the fun things is that, of course, they work the exact same way with multiplication as a string does. Right? Here I said L times 100. Rather than multiplying everything in it by 100, it said, okay, I'm going to replicate L 100 times. Just as though if I did, you know, BA plus NA times 100 to get a very big banana, right? So works the exact same way. So we can add these things together. Okay, so anyway, keep that in your back of your head. So for the original one, we created password, we added together all the things, we glued together, we concatenated together all the options we had into a single variable. Then we said, okay, for every character, let's go ahead and, we need 8 characters, so we're going to run the loop 8 times, choose a character, and add that character to the password. Now, I want you to do the same thing, but I want you to make a 4-word password, 4 words, from the nouns, verbs, and adjectives. Okay? Now, so that was me going over the previous one was my entire hint for this one. So take 5 minutes to do this one. Okay? I know it seems like we're making a huge leap. I promise you it's not. Because like I said, it takes the exact same operations. Okay? I'm going to go ahead and pause this recording. So let's go ahead and see. Okay, got about 24 minutes left. All right, so like I said for this one, we want since lists work I basically said, hey, this looks different, but it should work exactly the same, and it does. What we're going to do is do password is equal to blank, just like we did last time. And we're going to pull together our options again. Options, yes, not options, options, is equal to nouns plus verbs plus adjectives. And that's just going to take this and make it into one mega list. Okay? Then what we do is we do the same thing we did. For I in range, even though we're not going to use I, here it says it wants to be a 4-word password, so we're going to do 4 words. Okay? I in range 4, password is equal to password plus random dot, but what did we do here? We'll do word over here. Just because we're choosing a word, since we split it up last time, I'll split it up this time. Random.choice options. So we select the thing, and we're going to say the current password is equal to password plus word. Now, you're probably getting a bit tired of writing out the password twice, right? Like password is equal to password. So there is a hotkey for doing that, or a shortcut for doing that. And it's this notation, plus equals, okay? Which simply says, take this variable. It's just simply, when the interpreter gets to that, it expands that out into this. So it's commonly used when we do something like when we have x is equal to 5 over here, and then we do x plus equals 1, 6. So that's called the increment operation. Other programming languages have this, x plus plus. Python does not do that because it thinks, and if you're wondering, this is for the people who've taken another programming language. Why Java has x plus plus? It has that. Why doesn't this have that? Well, no, Java does have x plus plus, but Java also has plus plus x, and you're like, those things do the same thing, right? And the answer is no. They effectively do the same thing, but they do them at different times. So if you do something like this, if plus plus x is greater than 7 in Java, greater than or equal to 7. So x is currently 6. If you're in Java, or C, definitely C, if you do this in C, this will be true. If you did this in C instead, it would be false because of when it happens. So that is confusing because also you could do things like this, which of course is just this, and that would be terrible. And why are we doing this? This looks horrible to read. Don't do it. So Python really says we're going to get rid of things if it makes it harder to read, and it leads to confusion like that. That seems silly to let programmers really do something surprising, right? Python wants to do the least surprising thing. Okay, so here we have word, random choice, password plus equals word, and now we do print password. Okay. Error. Random not defined. What did I forget to do? Yes.
Import the random.
Excellent. 2 people at once. Awesome. Great. So I'm loving the enthusiasm here. Okay. So this one, again, an error I did not intend. I did not plan this on purpose. I just totally forgot to put it in. It happens. Don't beat yourself up about it. The key is to make the errors enough times that you're like, aha, I know what this error is. That's it, really it. The difference between, the reason I can do these homeworks so much easier than you can, besides the fact that I wrote it, is because I've made all the errors you're going to make like 50 times. And then I've corrected it for like God knows how many students at this point. You know, it is, so that there we go. Blue, fill, steady, okay. Okay. Speed, tissue, present, purchase. Insert favorite, statement, transfer. Okay, these are good random passwords. Now, mind you, they're a bit hard to read sometimes. Okay. Ooh, I know. So why don't we split them up by space? So we'll do this. Plus word, plus space. Just an empty space with the plus sign, like that. That's all. And now we get 4 separate words. Inspire, origin, seek, steady. However, this is like playing a bit of whack-a-mole here, because I can't just copy paste this to be a good password because of one thing. You'll type bad space kitchen space hat space basis, put that in, and it'll say wrong. That's not your correct password. Why? Because it's bad space kitchen space hat space basis space. Because you said, let me add a word, then let me add a space. This is not actually anything wrong you did or anything wrong I did in this case. You're going to do this all the time. This is something called the fence post problem, right? Where the idea here is that we have, here I'm going to use the eyes to represent a fence post, right? Suppose I have 4 pieces of fence post, right? And I'm making a fence, as I'm actually discussing with my wife right now. And now we need to put some pieces of fencing in between the posts, right? Well, there's 4 posts, but there's 3 things between them. And that's exactly what's happening here. We have 4 words, and I need 3 spaces between the words. It's a fence posting problem. So there's a couple different ways to get around that. The most direct way to do that is really silly and stupid, which is to do this. Run it 3 times, because we're repeating the exact same thing 3 times. And then the 4th time, we do it slightly differently, right? Which is that it's outside of the loop, the 4th time, and we just don't have the space. Okay? Now, this is environmental, shot, American, psychological, cruel, conclude, shock, suppose, disaster, clean, transform, American, rare, data, insert, date, inspire, and there's nothing there now. The other way to handle that, by the way, is and I'm going to hit share code, is once you know how to manipulate strings a bit better, you can just simply say, oh, well, if there's a character at the very end I don't want, let me get rid of the very last character, which is actually a really cool way of doing things in Python. Python is really cool like that. Okay. This shows you some other kind of functions you can use to do kind of replacements. So for instance, it kind of just shows that you could replace those O's with O's. Like that, with zeros like that. It's nothing to it much there. Run it for credit, okay? So you can get credit on it, because I want to make sure I go over this next piece, which is the hard part, before everybody goes. So this goes beyond what we've covered in the book, but we were talking about how long does it take to guess passwords, right? So let's simulate that, okay? So let's suppose we do have a 4-character password, which is terrible, right? No website will let you do that anymore. 4-character password, right? And it's composed of only lowercase characters. How many guesses would it take to guess the password? And we can write a program that will do that, actually. That's going to do that. And that's what I'm going to write right now. A program that will guess this password, but also more importantly, keep track of the number of guesses. So let's read through what it already has. And this is what I'll do in a lot of cases for when you're writing code, when I want you to add something to code on an exam, where I'll say, your code goes here, right in the comment, right below that. Okay? Nothing this advanced, though, for an exam. This is well beyond what I would do. Import random, we know what that does. Import system, and if we notice, sys for system only does one thing over here, which is this, right over here. Set execution limit 60,000, which says in the comment is 60 seconds. What this does is it gives in milliseconds the time limit for this program to run before it automatically crashes. Okay? Remember, the web page, the Python in our books will automatically crash the program within like 30 seconds, if it just as a kind of a security feature, just so that you don't clog up your own web page. Sorry, your own web browser. Okay? So this just simply says, well, this is a bit of a longer program, let's let it run for a bit longer. Okay? My password is ABCD, so that's what we're going to try to guess. We're going to try to see how long it takes for the computer to randomly guess this password. Guess number is 0. As we go through, what we'll do is that we will increment the guess number. Every time we make a guess, we're going to increment this guess number by 1 to say we've made an additional guess. And then at the end, it will print out that over there. Done is equal to false. That's a Boolean variable. Booleans are either true or false. And we see it being used right over here. While not done. So we have two types of loop in Python. The for loop, which you're being tested on here, you're not going to deal with the while loop until lab 6. The difference is for loops are what we call definite loops. They run for a definite period of time. It's going to be like for every item in the list over some item range. You use while loops when you want something to run an indefinite number of times, such as while the user hasn't answered the question correctly, or while I haven't guessed it yet, or while the computer is still turned on, right? Those kind of things. Okay, so some unknown number of time, but for some condition. So while this is not done. So this basically takes a Boolean thing, and as long as this evaluates, as long as the thing following the while is true, right, it will keep going. Now this is actually how I structure a lot of my loops personally, where I do while not done and set done equal to false. Well, it's not done, it means the opposite, right? While not done. So while true, here's the guess, create a new variable, which is called the guess password. Then we're going to randomly guess it. And if the guessed password is equal to it, it'll say we found it and set done to true. Once done is set to true, it's going to say, well, not true. Well, not true is false, so we're done. So this basically is, think of this like a switch. Done is false, and when we set done to true, we're done. Okay, so, and the reason why I like using it like this is because that's just so grammatically readable. While not done, it's very readable code. Everybody understands the meaning of it, even if you don't understand the mechanics of it yet, which is important. That's what really matters here. And that's why I like Python. It puts a lot of trying to make sure you can read the code, even if you only have a baseline understanding of the mechanics. So the guessed password. Okay, so we need to guess 4 letters. Okay, I'm going to go ahead and grab letters from up here. Boom. Okay, grab letters from up here. Okay, 4 in range. I'm going to go quick here because I do have one last thing after this. Guest password, guest underscore PW is equal to, plus equals random dot letters, random dot choice. See, I make mistakes too. I just have made the mistakes enough that I immediately delete the mistake, right? I immediately go back. Letters. And then after we're done making our password, we're going to do guess underscore num plus equals 1 to say, okay, we've generated a new password, and now we've made another guess. So run. And so now it's going to do this at random for a bit. right? And hopefully I didn't make a mistake somewhere. Okay, did I make a mistake somewhere? Or is it just taking a while? That's the issue with random, right? It's 4 letters long. All right. It works?
Slower, yeah.
Yep. It could be just I'm unlucky. In which case, you know what I'm going to do? I'm going to change the sample size. Okay? Let's go ahead and do a 2-letter password. Okay? And then set the time limit to very short amount of time. Okay? So it should be coming up on a minute anytime now. Error, yep, okay. So let's do 10-second time limit now. There, okay, so it wasn't, I was just straight up unlucky. Okay, I was just simply unlucky. That happens with randomness. So here with the 2-letter password, it finds it in no time in no time at all. Sometimes it takes it like 100 tries, sometimes it takes 1,000 tries. If we go to C, I got to remember to change this over here to 3,000. It takes actually considerably longer. In fact, it takes 26 times longer. Specifically, how long does it take? Well, we can get a grasp on that by looking at how many possible combinations there are. Right? A single password, right? Sorry, a single letter password has, if we're just using letters, has only 26 possible combinations, right? There's only 26 possible options. If we have a 2-letter password, there's 26 options for letter 1, 26 options for letter 2. That means you've got 26 times 26 possible combination, right? These are combinations we're dealing with, which means it's 676, which is about, so that's how long it would take. That's the amount of guesses you would need to make, assuming you had to deal with repeats and stuff, because that's what happens sometimes. A 3-letter password would be 26 for the first one, 26 for the second one, 26 for the third one, right? 26 additional combinations. This goes up pretty quickly. In fact, it's exponential. 26, so however many letters there are, right, if there's 3 letters, it's 26 times 26 times 26. If there's 8 letters, there's that many combinations. Okay, let's, look at that. Come on, how many are there? There's 100, thousands, millions, 208 billion possible combinations for an 8-letter password, only lowercase letters. Realistically, if you're using the minimums, right over here, there, and we're going to be kind of, then, let's say, there's about, so you've got uppercase letters as well. Let's suppose you throw them in there randomly. That's 52. An additional amount for your numbers. Let's say you're going to use maybe, let's say there's maybe, let's highball this and say there's 20 additional characters you could do. And bring that up to 82 to the 8th power. So 82 possible things, and that brings that up quite considerably. Thousands, millions, billions, trillions, quadrillions. It's very big. Now compare that though to, let's go back to just using lowercase letters. Okay, but make the password longer. Instead of using 8 characters, using 16 characters like we did for maybe a very short word password, just made of words. 26 to the 16 is considerably big. Sorry, 26 to the 16th power is considerably bigger. Millions, that's thousands, millions, billions, trillions, quadrillions, pentillions, hexillions, very big. Okay, increasing the exponent has a much greater impact than increasing the base, always. Okay, that's the thing to take away from this. Mathematically, increasing the exponent means it's gonna get to a bigger number, which means that the password cracking takes longer, even though the passwords look a lot less complex. Yes.
So, if you were to expand this to like anything that could be considered part of a string, it wouldn't be 26, it'd be like 100, right?
More these days because almost everything uses Unicode these days. Assuming you're only using ASCII characters, I'd say actually this is a pretty good, that 82 is a pretty, 90, because there's, an ASCII is a 7-bit thing with an 8-bit reserved for 128 additional things, but the ASCII characters also included non-printable characters like line break, line end of message, bell tone, like literally to hit the bell on the other end of the, to make the, literally a sound to make the computer beep. Well, like a character to make your computer beep. That is a character on your computer. Why? Because Morse code and other transmissions. That's why. So, all right, have a nice day.